Welcome to Introduction to Renewable Energy. So in this section, we'll be talking about electricity. Specifically, the sun is the primary source of almost all electricity we use on Earth. Most of the solar energy we use today is in the form of fossil fuels, which is essentially the solar energy that radiated onto the face of the planet millions of years ago. We'll discuss what is electricity and how is it made, the sources of electricity, non-renewable and renewable, and the sequence of sustainability. So first, what is electricity? Electricity is the flow of electrons from atom to atom in a conductor or wire. Everything is made up of atoms. The nucleus of an atom consists of positively charged protons, which are surrounded by negatively charged electrons. Atoms can gain or lose electrons. When atoms are aligned in a series, like a conductor, there is a potential for electrons to pass from atom to atom. When there is a flow of electrons, it is known as an electrical current. The outside forces that cause atoms to lose their electrons can be photovoltaic panels, a generator, batteries, hydrogen fuel cells, and many other different kinds. The common energy sources can be categorized as non-renewable energy and renewable energy sources. Non-renewable energy sources include coal, petroleum, radioactive elements like nuclear energy, and natural gas. Renewable energy sources include solar electricity, wind electricity, solar thermal, microhydroelectricity, biomass, biofuels, and geothermal heating and cooling. But what is non-renewable energy? Non-renewable sources are fossil fuels, or dead matter. They cannot be immediately replaced once they are removed from the ground and used. They can't even be replaced within human timescales. The world's natural gas, crude oil, uranium, and coal deposits took millions of years to form, and we will have used up most of these deposits in less than 200 years. Non-renewable energy is also inefficient energy. Coal starts out as a leaf. A leaf is 2% efficient in capturing the sun's energy and turning it into fuel. A leaf starts at 2% efficiency, then it is compressed over millions of years until it becomes coal. The coal is then mined, transported, burned, and the energy is put through the grid until it travels to the wall socket and is now a fraction of a percent efficient. When these non-renewable sources are gone, they are gone. Renewable energy, on the other hand, very quickly replaces itself and is available in a never-ending supply. It comes from the natural flow of sunlight, wind, or water around the Earth. With the help of collectors, we can capture some of this energy and put it to work. As long as sunlight, water, and wind continue to flow and plants continue to grow, we will have access to a readily available supply of energy. If not, well, then we have bigger problems than powering our electronics. Next, we'll look at the sequence of sustainability. The sequence follows the process that you should take to first reduce your carbon footprint, then implement renewable energy. The steps include conservation, end-use efficiency, closing loops, and then renewable energy. Conservation involves eliminating non-essential energy uses, reducing your overall energy usage, because the cheapest kilowatt hour is the one you don't have to make or buy. Behavioral changes require no money, but may save you a lot of money in the long run. Cutting energy use increases cash flow that can be applied to other steps in the sequence of sustainability. The important thing to note is that for conservation, you don't need to sacrifice comfort. You won't be shivering in the dark. You can easily conserve energy by turning off lights and eliminating phantom loads. Phantom loads are small uses of electricity that draw power constantly. Appliances with a built-in clock, or appliances that the second you turn them on, they power up, would be a phantom load. A television or computer that powers up instantly does so because they are constantly drawing small loads. To eliminate these phantom loads, you can use power strips and close the circuit so the electricity won't flow to these appliances when they are not in use. But remember, there's no need to shiver in the dark. If you decide that you want a phantom load, like a DVR to remember your channels or a digital clock on your stove, for convenience, just try to minimize your other phantom loads. A huge sucker of electricity is information technology. A typical personal computer left in continuous operation costs about $120 per year. When systems power down during hours of non-use, the operation cost can drop to $20 per year. The next step in the sequence of sustainability is end-use efficiency. End-use efficiency refers to reducing the energy input into your appliances by using more energy-efficient appliances. You can increase your end-use efficiency by using natural daylight, compact fluorescent lighting, or LED lights. You can also increase your end-use efficiency by replacing old energy suckers with their Energy Star counterparts. The Energy Star label is awarded to those products that meet or exceed established criteria for energy efficiency and are as much as 10% to 50% more efficient than their conventional counterparts. You can check out Energy Star appliances at www.energystar.gov. Many utility companies provide incentives for upgrading old appliances to Energy Star high-efficiency appliances. Check out www.dsireusa.org to find rebates your utility may offer. The next step in the sequence of sustainability is closing loops. This refers to the reuse part of reduce, reuse, recycle, such as converting waste like manure into reusable energy. While you can't do much to fulfill this step as an individual, you can try composting and using biofuels from waste veggie oil. The last step in the sequence is renewable energy. The sun provides 99% of the Earth's energy. The Earth is not producing non-renewable sources anymore, and we are using it at a faster rate than we can find it. Renewable sources use the resources that the Earth naturally produces. These are quickly replaced and are available in a never-ending supply. Using renewable sources diversifies the resource mix. When we rely on one fuel source, and that particular source becomes scarce, then energy becomes very expensive very quickly. Using renewable sources will slow down the depletion of fossil fuels and improve environmental performance because there are less pollutants involved. Even if you can't install renewable energy at your own home, you can almost always buy green power. Utility companies usually offer green power for purchase. Check with your utility company to find out if they have a program for you. As with any investment, there exists the law of diminishing returns. Energy independence is a very amazing concept, but we must apply the law of diminishing returns. The sun will provide a lot of heat and electric energy, but we can't just keep adding collectors. We will eventually begin to reduce the return on investment by costing more than the energy produced. It looks better to your pocketbook and cash flow to supplement your energy use with renewable sources rather than to be completely independent. That being said, it is an amazing concept and totally doable. In the next section, we'll take a look at passive solar construction and how we can use smart building to take full advantage of the sun's heat.